We're solving problem 23 from the 2024 F equals MA exam. Collisions between ping pong balls and paddles are not perfectly elastic. Suppose that if a player holds a paddle still and drops a ball on top of it from any height h, it will bounce back up to height h over 2. To keep the ball bouncing steadily, the player moves the paddle up and down so that it is moving upward with speed 1.0 meters per second whenever the ball hits it. What is the height to which the ball is bouncing? So, we're going to use conservation of energy equation later in this problem. But, so, if you're not bouncing it, the ball falls down at a velocity, say v, and then when it comes back up, this velocity that it initially receives from the paddle is going to be v0. And the upward velocity, new one, of the new ball is going to decrease in increments of square root of 2. So this is v over the square root of 2. Now, considering the case at hand, the next bounce will be so that the downward force, this ball has the energy v plus v0. And when it's coming up, it'll decrease by square root of 2, so v plus v0 over square root of 2. And then we can do this one more time, where it goes down as v plus v0 over square root of 2, and then bounces back up as v plus v0 over square root of 2 plus v0. Because we already have divided by square root of 2, this is the energy we're adding when you have the energy from the bounce. So you could say that our final velocity is equal to v plus v0 over the square root of 2 plus v0. Now, we can say that our velocity is equal to this. So, factoring this in simpler terms, we can take out this to factor out the v0. So 1 over the square root of 2 times v plus, well, this is going to be 1 plus 1 over the square root of 2 v0. And we have this, and what we really want to find is, well, this important part. So we can say that v is equal to 1 plus 1 over the square root of 2 on the denominator, and then 1 minus this 1 over the square root of 2 on the denominator. Then multiply it by v0. Now, multiplying both top and bottom by the square root of 2, this just yields, well, this is the square root of 2 plus 1 over the square root of 2 minus 1 times v0 is still our velocity. So we have this. And now, in this case, when we use conservation of energy, solving, or since we want to find the height, this, basically our height would be v squared over 2g, because the masses cancel in this case, as they are the same. Now, plugging v into this equation, we get that our height is equal to the square root of 2 plus 1 over the square root of 2 minus 1 squared times our initial velocity squared divided by 2g. And at this point, you can just simplify this equation with the numbers we have here, g being 10, so this is 20, and then simplify this expression up here to get our answer of 1.7 meters using 2 equals 1.414 as square root of 2.